Let's talk about calculations using significant figures. Before we can start doing actual calculations, what we need to figure out how to do first is determine the number of significant figures in a value. So in previous videos, for the measurement video, we talked about what the certainty was and how significant a value is when you're taking measurements using an instrument. That significance plays a role in any calculation you do using that value. So there are some rules that we must follow in order to determine what is a significant figure in a value. And I kind of break them up into three different rules. There is a rule where a particular number is always considered significant. If a number is considered always significant, it is a number between 1 and 9. Or it can also be considered significant if it is what we call an embedded zero. So this number down here, 101, is an example where you have a number between or embedded between two integers, and so that number is considered significant also. There are numbers where sometimes the number is considered significant, and this particularly pertains to zeros. So another kind of zero, rather than an embedded zero, is a trailing zero. And a trailing zero is a zero behind the last integer in a number. So here's the last integer in this number, 45.0. That means that this zero behind that last integer is considered a trailing zero. A trailing zero counts as significant only if and when a decimal is present in the number. So this zero is considered significant, but if you were to have, say, this number, 450, this is the last integer. This is considered a trailing zero, but there is no decimal, so this zero would not be considered significant. The last rule is using zeros where they're never considered significant, and these are what we call leading zeros. Any zero in any number, regardless if there's a decimal there or not, although you probably will only see zeros as leading zeros when a decimal is present in the number, if it is before the first integer of 1 through 9 in a number, so there are 3 leading zeros in this number, they are never considered significant to the value of that number. So given these kind of 3 rules, always, sometimes, and never, let's look at these following numbers here and let's determine how many significant figures are in that number. So all integers count. So right now there are 4 integers. And if you have any zeros in between your integers, those count also. So right here we have 1, 2, 3, 4, 5 significant figures here. All integers count in the second number, so 7, 6, and 5 count. These are trailing zeros, so they're sometimes significant, but there is no decimal in this number, so that means no, these don't count. So this only has 3 significant figures. This next number has 7, 6, and 5. Those are significant, yes. And then it has trailing zeros. They only count, remember, sometimes if there's a decimal present. So it turns out there is a decimal present, so yes, these all count also. So this is 6 significant figures. The next number, 7, is a significant figure, an integer. These are all leading zeros, so remember, all leading zeros never count before the first integer, and so in this particular case there's only 1 significant figure. This particular number is a number in scientific notation. When looking at the numbers in scientific notations, you're only interested in the value that comes before the notation part. So we're only looking at what's in the box here. And we apply the exact same rules as we have to any of the previous numbers. So here we have 1 and 4 are significant. We have a trailing 0, there is a decimal, that is considered significant also. So this will have 3 significant figures. So just determining the number of sig figs is actually fairly easy. what we want to do now is go to actually using these values in calculations. So when we're doing calculations of addition and subtraction, there's a particular set of rules that applies to these particular types of calculations, and that is, it depends on where the last significant digit is in place holding of that value. So for instance, in 35.7, the last significant digit in this number is in the tenths place. So that's important, keep that in mind. In the 22.15, the last significant digit in this number is in the 100ths place. The place that is furthest to the left in placeholder is the farthest that we can report an answer to. So let me show you this in longhand. So if we add 35.7 to 22.15, this is your last significant digit, last significant digit. The one that is furthest to the left, which is here, that is as far as we can report that number to where this line is drawn. I'm still going to use all the values in all of the numbers to do my addition. So this ends up being, let's see, 5, 8, 7, and 5. And with this particular value, what I'm going to do is any number behind the line, I'm going to use to round the previous number before that. There is a rule of when rounding using a 5 as that number to round. It is a little bit different than what you probably have seen in math class. What we typically do is we use this phrase, round to the even. And that means that the number before the 5 needs to be an even number. So if it is already even, it stays. If it is an odd number, we round it up to the next even number. So if this were 7, we would round it up to 8. But it's already an 8, so we'll go ahead and leave it as is. That means this value for this addition problem ends up being 57.8, and that value is 3 significant figures. So let's try this next one. The last significant digit in 120 is actually the 2. This trailing 0 is not significant because there's not a decimal in the number. The last significant figure or digit in 4.5 is the 5. So when we deploy the same rules, 0.5, what we do here is we add the 120 plus the 4.5. Well, this is the last digit. The furthest we can go, I kind of wrote that off alignment a little bit, is like that. So we have 5.421. Our 4 is a number that we will use to round the previous number. Well, the 4 is not large enough to make the 2 round up because it is below 5. So technically the answer to this value is 120. 2 significant figures. Okay. Our next value. Last significant value, or next calculation, last significant value is the 0 in 35.67. For 9.2, it is 2. So when we do our longhand subtraction here, is like this. 0 is significant, 2 is significant. The 2 is furthest to the left, so that means that's the furthest that we report. So this value will look like this, 26.470, and we use the 7 to round the number up. So our value here will be 26.5. 3 significant figures. Note how this answer has a value that is in 3 significant figures, yet this number was 2 significant figures and this number was 5. So when it comes to addition and subtraction, your answer may not necessarily reflect the same number of significant figures in your numbers that you use to do the calculation. So this is how you do addition and subtraction. For multiplication and division, it's a little different. The rule is the fact that your answer in multiplication and division problems is in the number of significant figures that is similar to the number of significant figures of your numbers used in your calculation, but the one that has the lowest number of significant figures. So for this, your 7 has one significant figure, and the 0.35 is 2 significant figures. So since the number 1 is the smallest out of 1 and 2, then your answer must be in one significant figure. So when you do your math, 7 times 0.35, in your calculator, you'll get a value that looks like this, 2.45. Your calculator doesn't understand significant figures, so you're going to have to round to the appropriate number of sig figs yourself. And so I want to go to 1 sig fig, so I start from the left to the right. That means 1 sig fig. So I'm going to use this number to round that number up or down. So it's going to stay as 2. That means 7 times 0.25 is actually 2. That is your answer, 1 sig fig. Let's do that for 10 times 12.5. This has 3 significant figures. This has 3 significant figures, so your answer should be in 3 significant figures. In your calculator, when you do this math, if you actually type these in exactly as is, the calculator will actually put out 125. And it turns out that that value is 3 sig figs, so you don't need to do any changing of rounding or anything like that. For the third calculation, 6,000 divided by 3.4, this is actually 1 significant figure, 6,000. 3.4 is 2 significant figures, so your answer needs to be in 1 sig fig. So when you put this into your calculator, however, it's going to give you this really long decimal number, and I get something like this. My calculator puts out quite a few decimals. But I need to actually round this to 1 significant figure. So that means to here. I still have to maintain that this place, has to be in the thousands place. So it has to represent 1,000. So I take this number and I round or not round. So my 7 is going to round the 1 up to 2. But then I will put zeros in the place of 7, 6, and 4 to maintain that this is the thousandths place. So this will be 2,000. That is the answer to that calculation. What if we actually take and put the addition, subtraction, and multiplication, division together in one calculation? What you have to do at this point is actually compartmentalize. And so you still have to make sure that you're doing the rules of order of operations of PEMDAS, got the D there, of parentheses, exponents, multiplication, division, addition, subtraction in order from left to right. So we're going to do our parentheses first, and this is our addition problem. So this is 11.45 plus 0.35, and that means the 5 are both in the hundredths place, so that's how far we'll report to. And that gives me 11.80 for that particular part of that calculation. And so we know that this is significant. So just keep that in mind, that that 0 is significant here. And then now we're going to multiply the 11.80 times 7.00. So we're multiplying now, and now we need to take into account the lowest number of sig figs. So 7.00 is 3 sig figs, 11.84 is 4 sig figs. Our answer at the end of this should be in 3 sig figs. So we get an answer when you do this in the calculator. My calculator gives me 82.6. And it turns out that that is 3 sig figs, so that is actually our answer. So let's do the same thing with the second problem. Let's take 10.5 and multiply it by 0.05. In my calculator, I get 0.525. Okay, but note that this number, this is multiplication, so we go by lowest number of sig figs. This is 3 sig figs. This is 1. So it really means that this number here should be in 1 sig fig, the 0.525. However, if I round now, that could affect ultimately my answer in the end. So what I do is I just keep in mind that it's 1 sig fig here, but I still leave the rest of the information of the value here. And what I will do is I will add the 125.5 to that. So this being the significant digit. So let me do that longhand just so you can see. If I have the 125.5 plus the 0.525, and let's underline the last significant digit. So do you notice how I'm underlining the 5 here, not the 2 and the 5 behind that? Because this is actually should be a 1 sig fig digit. So when I add this all together, I get 0 to 5, 6, 1, 2, and I know that I can only report as far as this tenths place. So I use the value back here, the 2 to round the 0. Well, it's going to stay as it is, so 126.0 is my value. On the last calculation, we're going to take and add a number 600 plus 3.7. That's going to give me a last significant digit, it means I can only report to the hundreds place. So 603.7 is really 600, okay? I'm still going to leave these numbers, but I'm going to make sure I underline that to know that that's the last significant digit when I'm doing my next kind of calculation using both sides. Now I'm going to take my 15 and I'm going to add 0.75. Last significant. I can only report to the ones place here. So that's 15.75. But notice how this 7 will now round that up. Do you see that? If I were rounding this right now. What I'm going to do is I'm just going to underline this for now, and then I'm going to add everything as is, or sorry, divide everything as is, and then I'm going to note that this was actually technically 2 significant digits, or significant figures, and this number was 1 significant figure. So whenever I write my answer, that should be in 1 significant figure. Okay, so when I get that, and I do the math, I divide 603.7 divided by 15.75, and I'm going to report this in one significant figure. My calculator gives me this really long decimal number, but I can only go to 1. So I'm going to go use my 8 and round my 3 to a 4. So really our answer here is 40. So this is how you do calculations with addition, multiplication, combinations of both, and how you determine numbers of sig figs in a value. So if you have any comments or questions, post those on the comment section on YouTube, or you can send me emails or bring questions to class.